Hey everyone, and welcome back to another Unreal C++ tutorial. And in this video we'll be looking at the SweepTrace options. So this is just another type of trace that you can do to detect or return information about objects in the world. We've already looked at two different types of line trace, and this is just going to be a very similar setup. To get started on this, I'll take the same approach as we have previously. So I'll go to our C++ classes and I'll create a new component in the component folder, and I'll choose the scene component type, and I'll name this one SweepTrace. Then when this is compiled and ready to go, I keep getting asked this, so I will answer this now as well. I am using the JetBrains IDE. I think it's called Rider. You can find it on the marketplace. Currently supports Unreal 4.25. But inside of the IDE of your choice, in the header file, what I want to do first of all is we're going to need the range at which we will do our sweep chase, so the distance or area covered. So I'm just going to create a new public float, which I'll name trace radius. I'll give it a default value of 500 units, and then I'll also give this a U property of edit anywhere, and just provide it a category named trace so it's easier to find. You could of course put this in a private or protected section to keep this kind of class safe, but because this is just to get this one very specific topic covered, I'll make this public so that we can easily change this in the editor if we wanted to. Then over in the code file, we just want to include the draw debug helpers.h, so the library to the debug helpers, as we'll be using this a little bit later to help visualize where our sweep trace is being run. Now, because we're not going to be adding movement or anything to this like I've done in previous examples, I'm just going to put the logic that we'll be using here in the begin play instead. So we're just going to run this once. We'll draw our sphere, which is probably going to be the shape that I'll use to show where the sweep trace is being made. So the first thing that our SweepTrace function needs is going to be an array of hit results. So I'm just going to create the variables ahead of time, and then we can fill those as soon as we go through. So for this one, I'll just create a T array of type fHitResult, and I'll name this one hitResults. Then the sweep is going to need to know where it will want to start and also where it's going to end. Both of these are actually going to be exactly the same, but in case you wanted to change this, we'll create two new constant f vectors, one named start and one named end. And both of these, because this is a scene component, so again this is going to be getting placed on another actor, we'll first of all call the getOwner function, and then from that we'll call the getActorLocation, so we'll find out where in the world the actor that this scene component is placed on currently resides, and we'll use that as the start and the end of our sweep trace. The final variable that we can pass in, or that we'll store ahead of time, is going to be the shape that we want this to trace in. So we do this by, again, I'll create a constant fCollision shape named ColShape, and this will be equal to the fCollision shape make sphere function, and this needs to know how large this is going to be. So we'll just pass in the trace radius, as we'll be using this exposed variable later to also control how big the visual representation of this is drawn as well. Okay, so next for the actual trace, again, like with any other trace that we've used before, if you've looked at the other videos, then this will just be returning a boolean when you have called the function. So we're going to create a new boolean called hit, and this will be equal to the getWorld, as the sweep trace we'll be using is within the world context, and we'll be using the SweepMultiByChannel. So as we can see here, the first thing I said it would be taking in is an array of fHitResults, which is our hit results variable that we've created just above. Then it will want the start and the end location of the sweep trace, which again we've created our f vectors, the start and end. We can also pass in a rotation if we wanted to, but we won't need anything here, so I'm just going to use the fQuat identity function, which will just return a rotation completely zeroed out on all of the axes. The next argument is asking for the trace channel. We didn't need to really declare anything here because again we're just going to call the ECC_camera. We'll always just trace on the camera channel. And then finally it wants the shape that the trace will be made in, and I should have mentioned previously you can make this things like cubes, and you'll have a lot of different drop down options where I've chosen the make sphere, but we're just going to use our ColShape, which will provide a sweep trace in a spherical location. Now again, this isn't going to give us any visual cues or hints on where this has been drawn, if it's successful, things like that. So to get around this, we're also going to create and use our debug helpers and use a draw debug sphere. To do this, we'll just use the draw debug sphere function. The context for the world, we can just use the getWorld function. This will then want a center point, so we will just use our start location for the sphere to be drawn around. The size of the sphere, again, we can reuse our trace radius, so this is why I've exposed this, is so that we can make sure that the actual tracing sphere that we're using and the visual representation of it are both the same. It then wants to know how many segments to fill, so this is just kind of visual fidelity of the sphere when it's drawn. We don't want this to be too high. Something like 50 will make this more than visible and easy to see. Next, we can pass in an F color. I'll choose orange, and then we can choose whether this will be persistent, whether this remains in the world. Because this is again just for demonstration purposes, I'm going to set this to true, which means that once this is drawn, it will not go away. Okay, so we now have our trace returning whether or not this has actually found something and a debug sphere to show where this has happened. So I'm going to use some of that information just to confirm that things are working as expected. So we'll use our hit boolean in an if check, and what we'll do is for each f hit result, which I'll set to be a constant type named hit result, in our hit results array. So we're going to go through the array in a for each loop, and then for each of these results we're just going to add an on-screen message. So we'll use the gengine add screen debug message, give this a key of -1, set the time to display to 2 seconds. Again, I'll just use an f color of orange. And for the f string, we use the print string, set the text to be hit, followed by a colon, and then the %s again to declare that we'll be expecting to pass in a string after this and appending a string to our message on the screen. And this string is going to be the result of the pointer of the hit result that we're currently looking at in the loop. And from this we can get the .actor, and we can use the getName function so we can return the name of the actor that we've hit. So again, you could use this for many different ways. You could find the location of the actor, you could cast to that actor and find out what it is, but we're just going to very simply return the name of it just to make sure we can see what we're hitting. With that all done though, we can compile the code and go back over to the engine and start looking at some of these changes. So I'll just compile that to make sure that we don't have any errors, and I'll show that result here, and we can see that has all gone through successfully. What I'm going to do then is create a new blueprint class. I'll set this to be of type actor, and I'll just name this BP_SweepTrace. Then inside of the class, what I want to do is just go over to the components section, and I'll place a SweepTrace class that we've just created onto this new blueprint. And again, you can see here that if you wanted to change the radius, that is now easily accessible. The 500 units should be perfectly fine, and then we'll just drag this into the world. I already have 2 objects here that we can check are going to be traced against so that we can return the names of those actors. Again, if you have seen any of my other trace functionality kind of examples, this is a very similar process just to get things confirmed that the process is working as such. But with that in the world, I'm just going to simulate play. We should see our orange sphere, and we can see I didn't leave that printing for quite long enough, but we are getting the names of everything we're hitting, which is the cube, the sphere, and the floor. So we can see that that trace has been successful. Everything within that spherical radius has been returned as a valid check. And again, we can just check that things like the radius are actually being taken into effect. So if I look inside of the class and find trace, of course needing to go to the actual component, and then we'll double this to, let's say, 1000. And if we press simulate again, we should expect this to be much bigger. It's not returning anything extra, but we can see that the radius is taking effect. And again, because we've reused that variable, that's working for the radius check and also the visualization of that radius. Okay, but with that done, hopefully that has proven useful, and you now know how to use sweep traces if you're looking to return information about multiple different actors or objects within a certain radius, and also how to correctly loop through the returned list of actors or the F hit results. But with all of that done, I'll leave this video here. As always, if you've enjoyed the video or found this useful, please do leave a like and share the video around. That really helps the channel and is greatly appreciated. And of course, to be kept updated with any of the content coming from any of the playlists on the channel, do consider hitting the subscribe button and pressing the notification bell to make sure that you get those updates. I release at least 1 video per week in some kind of tutorial form or covering a project that I've shared or created. So there's always something to come back for and check on the channel. And all of that is made possible by the awesome Patreon supporters. So again, a big thank you for all of your support over on the Patreon channel. It's great to see some of you coming into the Discord, and hopefully we can get that chat a little bit more active in there, the more people that come over and support the channel. If that's something you'd like to consider doing, then check for a link to the Patreon page in the description below. You can see all of the rewards and benefits provided, as well as helping to support the channel and the creation of future content. As ever though, thanks for watching, and I will see you all next time.